Stoten. I'm here with Theo Saville from CloudNC. Theo, thanks for joining me to chat today. Really excited by your business model and want to hear a bit more about that. But start by introducing yourself and telling me a bit about your background and what led you to this interesting revelation about the CNC industry.
Sure thing, Phil. So my background's in manufacturing, mechanical and industrial robotics engineering. And I actually started my career working in metals 3D printing research. It was back in 2010. 3D printing was quite literally all the rage. And I wanted to be working on that next industrial revolution. But the deeper I got into the research, and I was trying to build a new laser-based metals printing process, the more I discovered that the technology was actually incredibly niche and quite immature. And in fact, it didn't deliver what I wanted it to deliver, which is, single-click manufacture of anything. But the components, the products that we have around us, are not single components or even hundreds of components. They're thousands to millions of components, for example. And the autonomous manufacture of something like an iPhone or an aircraft or even a kettle is not something that can be achieved out of a 3D printer. So that got me asking the question of, okay, so if 3D printing is not the next industrial revolution, what is? And the thesis I over time built was it's going to be the shift from automation of manufacturing equipment to autonomy. Today, things are automated. You can take a machine and a person can write instructions for that machine or that robot, and the machine will follow those instructions. But every time you want to build something new, you need a person to get involved, usually an incredibly highly skilled expert. And this is why if Elon Musk wants to build a alien dreadnought gigafactory, he's going to go through several years of production hell, as is exactly what happened, because we've got automation, but it's still people who set everything up. The machines aren't autonomous. The next stage, the next revolution is autonomous. We tell a machine, make this for me, and it knows how to make it better than I ever could. We just specify the target and the machines are able to achieve the target, like you would expect from 3D printing, but for all kinds of manufacturing equipment. Now, the interesting thing is, if you can make machines autonomous, then suddenly all of the complexity drops out of running a factory, which means that you can make a factory autonomous. 3D files in one end, multiple processes autonomous to make your finished complex component or assembly out the other. And if you can have autonomous factories, they can talk to each other and you will have an autonomous reconfigurable supply chain. So if I look into the far future of manufacturing, I imagine it will be, not even single click. Someone's ERP system will be doing the clicking, saying, we need a new aircraft for this demand, autonomously order new aircraft, call it from an aircraft assembly autonomous factory. It will query the global supply chain of factories for capacity to build, instantly negotiate, and then start manufacturing. So rather than it taking 4 to 6 years to bring an aircraft into service, maybe it will take 4 to 6 days or weeks. I am 100% confident that manufacturing will look like this or beyond 1,000 years from now. I'm also entirely confident it will look like this 100 years from now. The question is, if we bring back time, at what point does it start to seem outlandish? And 5 years, that's outlandish. 10 years, 15 years, still a bit outlandish to get to that autonomous supply chain. 20 to 30 years, it starts to feel realistic to me that we will start seeing these changes en masse. I think that we'll see it in a small scale in as little as the next 5 to 10 years, but for it to become broadly how manufacturing works, that will take longer.
Yeah, and I think it's an amazing vision, and it's a vision that it kind of aligns with what I heard from Brian Kranich, the CEO of Intel, in one of those vision roundtables at CES 2 years ago, where he had this idea that you'd have autonomous design of products that were then put into production and delivered all the way to the consumer. Without anybody touching them, and it's a wonderful vision. But to do that, Theo, you've got to start somewhere, and you've chosen the CNC part of that process to start to automate, to start to autonomize. How have you tackled that, and what's the strategy there?
So I suppose the first question would be why? Why CNC machining? And we picked it because it's, to me, a machine that is most similar to a 3D printer in that it is a universal machine. It's like a computer server. What you get out of it depends almost exclusively on the instructions that you give it. It's a metal cutting machine that can cut any shape. It can make a satellite component one moment that's 5 millimeters across, and if it's a big enough machine, it could be making an oil and gas component 5 meters across the next hour, although that would probably take several weeks to machine. But they're like servers. They're incredibly flexible, which really lends them to building a fully autonomous process.
So why do you think CNC is ripe for disruption and ripe for this revolution?
So the market is vast to start with. Just what we can see of it is $168 billion. That's almost 3 times Uber's TAM and growing at 12% a year, because there is literally nothing that you can manufacture without a precision component in it. Doesn't matter if you're trying to make a carpet, a car, or a satellite, you need CNC machined components, either for your finished good or for the machines that will make your finished good. So it's one of the most fundamental building blocks of the industry, and it's a broken industry. It's served by 100,000 mostly tiny factories. 98% of these factories have under 100 employees, half have under 5, half don't have an ERP system. I've walked shop floors last year that still use floppy disks. It's incredibly technologically backwards and constantly disappointing its customers. Average on-time delivery in the industry is just 89%. Average gross margin is 9%. And the defect rate hovers around 2 to 4%, and 5% is scrap. These are all incredibly poor performance metrics. And it's not from a lack of will. This is a very capable industry filled with extremely expert people. It's because the scale of the problem does not lend itself to the human mind. There are trillions of ways of making even a really simple component, and there are trillions of ways of managing your factory. It's just beyond our capability to manage that complexity, which is why these factories never get big. As you add more equipment, the complexity exponentially grows. So unless you're making the same thing millions of times, say you're Foxconn and you've got an Apple contract, you can have 75,000 machines because they're all doing the same thing. That is an incredibly rare edge case. Everybody else has to deal with this incredibly high mix, high disruption prone industry in which it's virtually impossible to scale. What's the answer to that? Make everything autonomous. If everything is controlled by software rather than the human brain, software is scalable. Software doesn't make human mistakes. It means that if you want to scale up production and you have an autonomous process, you don't need to add more expert people. You just need to add equipment. It's like growing a server farm. So that's exactly what we've been working on for 5 years, solving the problem of creating end-to-end autonomy in CNC machining. How do we price, schedule, program the machine? How do we manage all processes and distribute workload in order to take a 3D file and turn it into a part with no human decision making involved in the middle? Now, that's not the same as no humans. Robots are really overrated, I find, in manufacturing. We look to them and we see them a lot because they're present in the very sort of tip of the iceberg in manufacturing, the massive car plants that people think of when they think manufacturing. But that's a really rare edge case. The 99% of manufacturing is too small volume to be able to invest time in robotics because robotics is so inflexible today. But what's great is highly efficient instructed humans, like you would find in an Amazon warehouse, that is incredibly efficient, much more efficient in many cases than investing the time in setting up robots, until we can make those autonomously reprogrammable as well.
No, I can see the logic there. So we're talking about a situation where we have data in, parts out. That's the objective. Initially, the objective is to have that on an individual machine, then have that on multiple machines, then have that on multiple factories, and that's how we create this this autonomous manufacturing trend. Where are you in that journey? Are you at the point where you can fully manage the production load and the programming of a single machine with data? And how does that roadmap look going forward?
Sure. So we're about 5 years in on the journey right now. So true deep tech problem, incredibly difficult to solve. And around 6 months ago, our autonomous machining tech left the lab. and now it's at the point where it makes parts for customers every single
Hmm.
day, and its usage is growing at an exponential rate month on month. So a very exciting time for autonomous machining tech.
Mm.
In terms of spreading that over multiple machines, we just began that. And one of the other pieces of autonomy we've been building is a very advanced scheduler able to spread this workload over many machines and schedule right down to the level of individual people and tasks. Today in scheduling, the schedulers are basically useless. They will tell you roughly what a machine should be doing maybe on a day, but they're very unreliable. This scheduler is the answer to how do I give someone an iPad that tells them what the most important thing they could be doing at any particular time is so that they can do that thing and it is scheduled to
Mm.
optimality. And then what if there is disruption? How do I immediately recover from that disruption because I have backup plans? So those two pieces of technology are deployed commercially in our factory and now incrementally improving, which is a very exciting time and place to be.
Yeah. Yeah, no, that's fantastic. And I see that as being hugely valuable. And you talked about the poor statistics and poor performance numbers that you see as typical of the industry. Roll that forward to where you are now and where you want to be. What is the incremental improvement in terms of those performance metrics, those KPIs?
So when we've been using autonomous machining tech, we've never shipped a part late, and we've never shipped a bad quality part. I did once have some parts beaten up in a box because they weren't packed properly. That's our bad.
Hmm.
But it makes it easy to achieve perfect on time and perfect quality when the software is in control. Um, which is wonderful.
What about the efficiency of the machines? What about when you look at that initial stage of autonomy, data in, parts out, one single machine managing its workload, how much more are you getting out? How much more can you get out of a machine by doing that as compared to having, manual programming, manual production scheduling?
So right now, about 1.6x more, with a
Wow.
massively reduced headcount involvement as well. But we know that it's possible to get to 10x more, and that's the incremental increase that we'll be driving over the next 4 years as we add
Mm.
capability to the software. Part of that is driven by a increase of the speed of the machine. So right now we can make the machine go a multiple time faster than if a person were programming it because software is more capable. We just need to add more modules, whilst also increasing the utilization of the machine. When you make the process autonomous, the bottlenecks start falling away, which makes it very
Hmm.
much easier to achieve high machine utilization. In industry, that utilization is only 26%. On the autonomous
Wow.
machine, that's already 50% on average, even though it's making ultra high mix work, which is the very hardest kind of work to achieve high utilization on,
Mm.
because you normally need people to be reprogramming everything, proving out, testing quality, all of these things that make it hard to make a machine keep running. But if we fast forward that up to 2024, we know we can make the machines go at least 3 times faster on average, 10 times faster in many cases, and we know that we can get 4 times more utilization out of the machines, whilst also delivering service levels that are impossible by today's standards, like aerospace
Yeah.
quality parts within 24 hours or same day, even if they're incredibly complex. People are willing to pay a huge amount for that. And all of those things will
Yeah.
combine to a more than 10x increase in productivity.
Yeah, and when I look at that customer value management situation there, or I look at how that customer value management is going to be measured, obviously that optimization of performance is huge. People are going to be very, very happy about that. I think what they're also going to be very interested in is what does it mean for the pricing. And when I look at a CNC or a machine component, I figure there are two elements in there. There's material and then there's machine time. Basically,
Mm.
I don't know what else there is in there. And if you're optimizing the machine time, I don't know what the relationship between those two is, but I imagine you're able to drive some very competitive pricing as a result of doing that. So you're adding value without adding cost, I assume.
Exactly. So we aim to be 20% cheaper than the competition at any particular service level and
Hmm.
improve that in the future still. Um, and as to the value we want to deliver to the customer, effectively what we want to build here is the Amazon Web Services of manufacturing. So many things are possible because as a startup, we can just pull flexible compute out of the cloud, and it is infinitely scalable. It's very, very cheap. It's incredibly reliable. That's how machining should be. And it's what I like about the machining industry. It's kind of like the cloud compute industry for manufacturing, in that you've got this one machine that makes all of the fundamental components for everything. And depending on the instructions you give them, just like a server, they will make something different. So I see an opportunity to build that service, which is I want 1,000 of this and 5 of that and 6,000 of this, and just click buttons and get these parts and never have to think about it, for it to become like that cloud hosting service, rather than the incredibly complex situation we have right now of I've got a supply chain management team that deals with the 4 factories that I have agreed to work with and is constantly looking for more and managing their screw ups. That's not how manufacturing should be. It should be, one click. Forget about it.
Yeah, order it and upload the data, and the part is delivered on time. That's it. That's exactly what you want. And when you look at, you mentioned disruption, and we're used to disruption in the industry for various different reasons, and we've had lots of disruption this year. But you talk about high mix, and that's just naturally disruptive. Do you see a situation where you've got work scheduled in the factory by the autonomous system, and if a job comes in and it's a 24-hour job or whatever, the system is able to identify a slot where that can go in, where it can push and pull capacity? Is that something that's possible, or do you end up with a very rigid plan?
Oh no, quite the opposite. So it's closer to the first thing you described, and then a lot more. So our scheduler runs right now what we call what if analysis. So it doesn't just look, can I fit this in here? It looks, where could I possibly fit it in? What are all of the useful scenarios to the customer, and how could we reshuffle our entire plan? Which sounds really easy, but scheduling is actually an NP hard problem. If you think of a factory with 10 machines, which all share resources, people to program them, people to test quality, people to prove out the programs, people to load them and operate them and maintain them, you've got already millions of possibilities. Add another couple of machines and you've got trillions of possibilities. That's an incredibly difficult problem to manage. And then if you want to go and start asking, where can I fit this job in? That's when things start getting really complicated. So yes, that's exactly the sort of thing that we're building. It should be possible to, for example, split that production across multiple machines and multiple times, to put it in different slots, to maximize the chance that as much of it as possible is always delivered on time, even if there were a disruption event, suppliers late, materials not there, somebody's sick. How do we get the greatest amount of utilization from the machines to deliver low cost to the customers, whilst also raising the utilization as close to 99% as possible without failing? That is the challenge of scheduling in this industry.
Yeah, and then the last element of that I want to talk about here is the supply chain. So we talked a lot about what happens inside the factory, but when you're scheduling those orders, you've got to know the materials available, or you've got to know what material you've got to buy. Is that part of the autonomous system? Does it manage the supply chain of the metal pieces that are going to be machined?
Yes and no, and moving to all yes around the middle of next year. So we don't just build software that makes the machine autonomous. The overall package is called Factory Operating System, and that is autonomous machining tech. It's the advanced probabilistic scheduler. It is autonomous workflows and pricing. It's a business intelligence system. It is the answer to that question of, we want to take a customer requirement and turn it into a 3D object delivered to them with no decision making in the middle, and getting material from suppliers is obviously a part of that. Now, the great thing about having autonomous machining tech is you can take a 3D file and work really easily back from that exactly what the stock material should be, which means that you can, of course, autonomously order that from your supplier or call it off the shelves, or with the business intelligence system, do the analysis to understand what materials should we be holding in stock on consignment at the supplier, and then what should we be ordering in custom, and then leave the system to worry about doing those things.
Yeah.
To leave it to the system to say, this order's come in, okay, you please go to the sawing machine or the automatic sawer and request these billets, and then you please take those to that machine and set up these tools. These are all, in a traditional factory, entirely human decided and driven tasks today. Should all be autonomous.
Yeah, and will be. Absolutely. It makes perfect sense. Great insight, Theo. Really fascinated to see how this plays out, and I'm looking forward to when we're no longer in lockdown to be able to visit the factory and see it in operation. But in the meantime, thanks so much for your time, and look forward to talking again soon. Thank you.